Hello everyone, let's welcome to my channel. So here we are going to discuss the KSET question of ordinary differential equation. So they have given you y1, y2 are the two linearly independent solution. If any differential equation is given to you, and if they say that y1 and y2 are linearly independent solution, it means that the Rankine of that solutions, the Rankine of y1 and y2 is always going to be not equal to 0. If they say that linearly dependent, it means that the Rankine of y1 and y2 is going to be equal to 0. But they have mentioned that linearly independent. They have given you the y1 and y2, they are the solution of this differential equation, but they are linearly independent. It means they are linearly independent means the Rankine is going to be not equal to 0. So, and they have given you one more thing, the differential equation, where the x value is going to lie between 0 and 1. And they have given you one more thing, that g of x is equal to Rankine of the given solution. G of x is nothing but equal to Rankine of y1 comma y2. Okay, so it means here the Rankine is, here we got that Rankine is not equal to 0, but they have given you that the Rankine of your y1 y2 is equal to g of x. If Rankine of y1 and comma y2 is not equal to 0, automatically g of x is also not equal to 0. Okay, then we have to check that whether the g dash of x is going to be greater than 0 whenever the x lies between 0 comma 1, or g dash of x vanishes at any one point. We have to check whether the g dash of x is going to be 0 at any one of the point between the 0 to 1, or it's going to be less than 0 at any one point at the point from 0 to 1, or we have to check whether the g dash of x going to be vanishes at all the point. So here they have given you y1 and y2 are linearly independent. So Rankine is not equal to 0 and g of x is also not equal to 0. So here we are to check these options, which one is correct, we have to apply the Abel's formula. What is Abel's formula? The Rankine of that y1 comma y2 is nothing but it is equal to a, where the a is a constant, e raised to power exponential minus of integral of a1 of x by a naught of x with respect to dx. What is a1 and what is a naught? A naught is nothing but coefficient of your y double dash. The given differential equation is in this form: y double dash plus sin x of y is given to you. So a naught is nothing but coefficient of your y double dash, a1 is coefficient of your y dash. In this given differential equation, the y dash is not there, the coefficient will be equal to 0. So a1 value is 0 and a naught value is going to be 1. Okay, so integral e raised to power of the integral of 0 is going to be 0, so e raised to 0 is 1. So here we got that Rankine of y1 comma y2 is nothing but equal to the constant a. So Rankine is also nothing but it is equal to g of x, so g of x value will become a. So here we got that g of x value is nothing but a constant a. That constant may be anything, it may be 1, 2, it may be 3, it may be 4, any constant. So what will be the g dash? Because here in the option we are talking about only g dash, so we have to take the derivative of your g of x with respect to x. It will be a is any constant, it will going to be 0. The g dash of x is going to be 0 for every point, because the g of x is 0, it doesn't depend upon the x value. The g dash is always going to be 0 whatever the x value is there. So which option is correct? So here g dash of x is going to be 0. It means g of dash x going to be vanishes at all the point. So the option D is correct.